Okay, so in this video we're going to talk about how to make a binary phase Fresnel zone plate. And in the last video, 601, we talked about the binary amplitude. We actually use the same file, same bitmap file that's used for the binary amplitude, except now we're going to be writing in a grayscale photoresist. After you go through the linearization procedure for the depth of the photoresist, you want to find out how deep each of these alternate zones need to be. Now with a positive resist, what's going to happen here is in the white area, zoom in on that, that's going to create a deeper pattern than the black zones. So that is going to be lower in the photoresist than the black when after it's developed, and we want to know how deep that needs to be. So our particular photoresist is, sorry about that, left over from last video. A polyimide resist. So what we'll do is figure out the photoresist refractive index at the 686 nanometers. We'll go into glass dispersion calculator under accessories, and we're going to browse for the file that we need for the glass data. That's in the Optiscan main directory when you load it in. And in mine, that's on C under Optiscan and version 7.3, glass files. And the one that we're using is AP2205 Norwood. That's index of refraction measurement for this material, and it seems to be working pretty well for us. So it asks you if you want to replace it. You don't actually have to replace it unless you go in and edit it. So again, this is kind of a programming thing that I just never got around to changing. But you can just say yes here, and then plot file data. And like I said, as long as you don't go in and edit and then save it again over these data, you'll be fine. So this is the plot from 400 to 1.6 microns, 400 nanometers to 1.6 microns. And to get 686, we'll just go in here, select the zoom tool, 686, here, 686, it's right there. Okay, so we are at 1.5937 for the refractive index. So in at 686 is 1.5937. Okay. So the depth that we want, the height, is that we need to put into the photoresist is the wavelength, 686 nanometers divided by n-1 because we're going into air, 686 minus 1, and then divided by 2 because we want a pi phase depth. So our height in the resist will be 0.57773 microns. Usually if we get 0.57 or 0.58 microns, that should be fine for that depth. Okay, it'll be a little bit of phase error there, but that's not too bad. And that's how you do it.